Here we are taking up page 308, question number 9 for our Nelson textbook in MPM 2D. The equation that we're given for this question is that the area of the rectangular field is defined by negative 2w squared plus 36w, and the question's asking us to find what is the maximum area of that enclosure. So if we're needing the maximum, what we're really looking for is the y-coordinate of the vertex. Now, this equation is given to us in its standard form. From the standard form, the only thing I know about my parabola is that it's opening down and slightly narrower than y equals x squared. And the y-intercept would be a 0 because I have nothing as a constant term. I have a plus 0 on the end of it. Now, what I can do with this, though, is I can factor it, and factoring it will allow me to find my x-intercepts for this parabola. So if I factor this, it does have a common factor, and I like to take the negative because my leading coefficient is negative. I'm going to take that out as part of my common factor. 2 can divide both the 36 and the 2, and w is common to both terms. And when I divide the original expression by negative 2w, I'm left with a w and a minus and 18. When 36 is divided by 2, we get 18 there. So if I were to re-expand this, hop through, multiply through, I would get back to my original function that I had on the line before. Now to find my x-intercepts, I'm really letting y equal 0, or in this case, instead of y, I have a for area. I'm letting the area equal 0. So I'm going to put that in here. So the area is 0, and it is equal to negative 2w times w minus 18. The only way we're going to get an answer of 0 when we're multiplying two things together is if one of those two things is actually equal to 0. So we could say, well, either negative 2w is equal to 0, or the w minus 18 has to be equal to 0. So what we're doing is we're solving for the values of the width that would give an area of 0. So I'm going to solve by dividing both sides here by negative 2 on this one, and I get w being equal to 0. And that should make sense because in a rectangle, if I had a width of 0, and I'm multiplying it by another number, 0 times some other number will still equal 0. And if I have no width, how can I even have a rectangle? Let's face that. That's kind of weird. All right, now I could add 18 to both sides on this one, and I get w is equal to 18. So it's saying if my width was 18, then the area of this rectangle is 0. And that's probably because then the resulting length would be a 0 value. So 18 times the length would end up being a 0 there. Now, how does that help us? Well, let's talk about the sketch. What is this going to look like? So I said at the beginning our parabola should be opening down, and our y-intercept is at 0. So this is our w-axis. This represents the independent variable of w. My y-axis is really my dependent variable of area. And I have my x-intercepts, or in this case w-intercepts, at 0 and at 18. And my parabola opens down. So that means if I were to sketch this, I'm going to have my parabola coming up and then coming down. And we know parabolas are symmetrical. That means that halfway between the 18 and the 0, that will be the value of the width that's going to produce the maximum area. Well, to get that value of the width, we're going to add those zeros together and divide by 2. It's the midpoint. Now that one's pretty obvious that it should be 9, but in case you're not sure, that this is the process that will always work, especially if we're working with decimals. So the value of the width that's going to produce the maximum area is 9, and now to get the actual maximum area, we're going to take that 9 and substitute it back into the area equation. So our area equation, we can work with the original that we have here. Whoops. That should be w. And we can sub in the value of 9. And then we can calculate that. And when I calculate negative 2 times 9 squared, I got negative 162. And then 36 times 9 was 324. When I combine those, I get positive 162. So the coordinates then for my vertex here would be 9. That's the value of the width of the field. And the area is 162, and this was in meters, so the maximum area is 162 meters squared, and it occurs when the width of the field is 9. And so, of course, I write a therefore statement. The maximum area of the field is 162 square meters, and it occurs when the width of the field is 9 meters.